Ready. All right, so now Blade is here. We can finally get started, do our work. So, class.
Yes.
Okay, not bad, not bad, not bad. Okay, for those people actually paying attention and doing notes and not on their phone for some reason, okay, staring at their Danimal. Okay, so yes, okay, yes, it does have red dye, and yes, it is poison. So it will kill you. All right, so obtaining information about the graph of f from the graph of its derivative. Now, this right here is probably the most complicated because everyone sees something and they don't understand what it means. Every year I go through this, we have trouble because you can't visualize it yourself. Looking at a graph. This is a graph not of the function, but of the derivative. Am I missing all my... Where's all my markers at? Tree, do you steal my marker? No. Okay. So, a function, so it doesn't say where the function is continuous for all real numbers. The graph of f prime means this is the derivative. So now, we got to pay close attention. Right here. What does that mean? The derivative is 0. Okay. Okay, so that, very good. So the slope is 0 at that point. Okay, so now let's continue with that. So that means that everything over here, what's the slope over here? What's the slope right there? It's all negative. All those numbers right there are negative, aren't they? Okay, so it has a decreasing, and it goes right here to 0. Then what happens after that?
Oh, that would be a
What happens right here?
It stays decreasing.
Stays decreasing, doesn't it? So since it stays decreasing, I'm looking at my slope. Okay, it goes down, 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 down to 0, and then it goes down again. So it's going to look like this. So it's going down, 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 down to 0, and then down again. So that's what this is going to look like right there. Right? Okay. Now, let's take a look right here. Right there. What do you think that's doing? It's changing, right? It's changing. So that means it's decreasing at an increasing rate. It's decreasing at a increasing rate. Then at this point right here, it goes from decreasing at an increasing rate and over here, and now it's decreasing at a decreasing rate. So right here, it's decreasing at a decreasing rate.
No, it's decreasing at a decreasing rate. It's decreasing at an increasing rate. They're opposite.
Are these numbers getting bigger? Is this number right here bigger than this number right there? Because as it goes further down, isn't that a bigger negative?
No, I know because it's always confusing because you think it would be decreasing at an increasing rate, but it's decreasing at a decreasing rate. Oh, yeah. And then decreasing at an increasing rate is when it gets more positive. Yeah, because it has to do with concavity.
The numbers are getting bigger, but they're getting more negative.
Yeah,
more
so
away
it's
from zero.
decreasing at a decreasing rate.
Yeah.
Is the slope increasing or decreasing?
No, it's...
Is the slope increasing or decreasing?
The slope is increasing.
It's increasing, right?
But you said on the second part, isn't it increasing at an increasing rate?
Decreasing, because the slope right here, let's say, let's say that's -10, that's -5. Okay, over here this is -1. This right here, let's pretend that's -5. So goes from -5 to -1. My slope is it's the rate. It's the rate of the rate. So think of the acceleration basically at the rate that it's changing. So here. Let me do. I got Blade over here. Okay, Blade's driving. Blade's driving. Okay. So he starts here. He's going to go right here. So his speed is, it's increasing, right? Okay. And the rate, what's the rate? Is it the same all the way? So there's no changing that. So now let's try this one. Increasing at an increasing rate, right?
Yes, and if it was the other way around.
I'm going there. I'm going there.
It'd be increasing at a decreasing rate. But when it's negative.
Increasing at a decreasing rate. Okay.
That's just decreasing.
Okay. That is. Okay. It's a steady rate, right? Okay. So at the rate, the rate's not changing, but it is increasing.
Yes.
So the whole thing is just decreasing, right?
Yes.
So it is decreasing.
That's decreasing at an increasing rate. It has to do with the
I might be wrong. I will search this one.
concavity. It's at an increasing rate when it's concave up, and that is concave up. Therefore, it's decreasing at an increasing rate. It doesn't actually have to do with whether it's decreasing at a decreasing rate or an increasing rate. It has to do with the concavity.
Okay, so decreasing. Let me see. Decreasing at an increasing rate. Increasing at decreasing at a decreasing. Hey, you're right. You're right. Maybe that's why. Okay. Concavity, good job. You proved me incorrect. Good job. You get a payday. Ugh. In your face. All right. So, if it was me, I would write these things down right here because I screwed this one up. Or you could just, stare awkwardly and, try to drink your Danable. You guys didn't even get up to get notes. They're right there. I said it, but you guys weren't even paying attention when I was telling you. All right, so apparently I got it wrong. So let's go ahead and fix that. So I'm going to change mine because I made a mistake and I don't like being wrong. Okay, so this is going to be decreasing at a decreasing rate. And from here, it is decreasing at an increasing rate.
What is split up between
Say what again?
Where are you splitting it?
Are you splitting it between the
Right here when this is 0. At this 0 right here. I haven't got to this part yet.
Okay, so it's like
I haven't got to that part. I'm just talking about from here to here. And so right here, I go from a negative slope. This right here goes to 0, and then it's a positive slope. So what type of thing goes from a negative slope to a positive slope? Throw up those gang signs. Huh? Which is it? Throw up your gang signs. Because it goes decreasing, right? Decreasing. And then it changes to increasing. So, again, me telling you about the throwing up the hand signs every time, hopefully it's helpful. I'm not doing this for my health. Maybe I am? Yeah, I am doing it for my health. There we go. So, anyway. So, right here, going down and coming back up. That means that is a minimum. So right there we have a minimum at 2. So, let's go with critical numbers. So what critical numbers do I have here? 0 and 2. What are critical numbers again? How would I get a critical number? Derivative equal to 0. That's key, especially trying to identify where these are at.
Wait, but I thought, is 0 still a critical number because it's not a min or a max?
It just starts off as a critical, but it's actually not going to be a min or max, but it still counts as a critical. Even though it's not going to end up being one of our things. If we had something that had 4, and some of them mins, maxes, all that other stuff in between, it's still a critical number where I have to do what with it? I have to test it. I have to go plug it into the function later on to see what I'm going to get. Okay? All right, so it starts off there. Where is it increasing? This graph is increasing from?
But increasing, where it's increasing would just be where it's positive, yeah?
Yep, only positive slope, right?
So from
2 to infinity. There we go. Now, am I including 0? No, 0 is not. So that's why it is a parentheses. Where is it decreasing? It's decreasing from at what numbers does f have a local minimum? Does it have a local minimum? Say what again?
How is it from infinity to 0 decreasing?
This one right here?
Yeah.
What's the slope over here?
It's negative, but it's increasing.
No. This is a graph of the slopes. All these are negative. So this is a graph of the derivative. So everything here is just a slope. It's all negative slopes there.
Oh, F prime?
Yes.
And real quick, I noticed between parentheses and brackets around there, the homework, as I saw too, so I was wondering that too, and the answer showed brackets and parentheses.
Depends on what it is that we're getting. So from this graph, I'm not saying it's 0. So
But then wouldn't 2 not be the one that exactly is split between?
okay, so one more time.
Would 2 have a bracket?
Parentheses. Because it's going up to 0. The y value is 0 right there, right? So it's implying that what is the slope right here at 2? 0. So all this right here says it's 0. All that is 0, right? Whenever it touches that line, my slope is 0. Yes?
Yeah.
Okay. So if it gets there, right here, it's going to be neither increasing nor decreasing. Is that what you need?
Yeah, I was asking. I was gonna.
Yeah, it's a whole box. Go ahead. Throw it out. Grab a new one. Did I answer your question?
Yeah. I looked at all the homework.
Okay. Hey, I don't. If I'm wrong, I'm wrong. Okay. But yeah. 0 does not count as a. It's neither positive nor negative. So for it to be decreasing, it can't be 0. It goes all the way up to 0, but not so.
Yes, but wouldn't it just be like a immediate switch though?
Wouldn't
Wouldn't it just be like an immediate switch though? Like, or would it be like the little curve when it passes 0?
when it passes 0, the other so right there. So it would be negative, negative, negative. So if this is a graph of my function, so it goes negative, 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 negative right here, and then it starts going back up. So if this is a graph of my function, so if this is my function right here, it goes up to this point. My slope right here is 0, right?
Yeah.
My slope is 0. It goes down, and then it comes back up. So right there, if that was my function, so we'll eventually get to the point where we have to try and sketch the function given the derivative. Because we know that's a minimum, right? Okay, and we know over here just goes off that way, all the way infinity, right? Yes. Yeah, that's what I've been trying to get to, but like, randomness, thanks. Keep having to tell people to take out notes and quit, drinking or Danable. I'm trying to get there. But this is the one problem I wanted to go over. Okay. So. Yes, maybe?
Yeah.
Okay.
I don't know.
At what x does f have a local minimum? Local minimum is? It goes from decreasing to increasing. Is there any place where it goes from increasing to decreasing? This one doesn't have one. Because it doesn't change. It doesn't go from increasing to decreasing.
Would it be more? Would it be like more appropriate to say positive to negative since it's a graph of the slope?
Yeah. Yeah, that's right there. So that's the only place it actually changes from a negative to a positive. I don't have anywhere here where it goes from a positive down to a negative. Okay? All right. I was trying to, there we go. All right. Let's leave off there. That's basically what it is I wanted to get so we could have time working on homework. So, like, share, and subscribe, and hopefully, yeah, people will not waste this time.